Oh no. Oh no. Uh, so yeah, I should just report it. All right. Um, so I thought I had like a project that I wanted to use for the last assignment, but unfortunately, like I can't find it. But we are still going to do something, sure, which is just basically go through like the role of what decision tree use and all of that. Um, I've really had like a busy week and all of that, so it's not been easy to prepare school. And we are all going to look at this together regardless. Let me just prepare workspace that I would be using. All right. Um, all right. Can you guys see my screen? Can you guys see my screen?
Yes.
Okay. Um. All right. So the last stuff you guys did was basically decision tree for classification and regression, and we also talked about bargaining and boosting and model tuning. Yeah, and also the bias variance trade-off. So going through all of this, let's see what we can cover to the end of this session. Okay, so starting off with classification tree, it's like a sequence of if-else question about individual features, and it captures non-linear relationship between features and labels. So, does anyone here know what a linear relationship is and non-linear relationship is? Uh, Someone sent a message. Oh, I'm not very clear. Oh, sorry. Sorry. Is it better now? Hello, like I sort of like increased my voice. All right. I guess I'll just have to speak to his voice. All right, so let's just move on. So yeah, I was talking about classification tree, and I was saying okay, it's a sequence of if-else question about individual features. So classification tree basically like helps to use each features to determine like the target, and it also helps to find like capture non-linear relationship between features and labels. So there are some features that do not directly impact the labels, but that do not directly affect the labels. So classification tree can help to also find that relationship. And also it doesn't require like feature scaling, which is normalization or standard scalar and all of that and all of that. So here is a data set of breast cancer in 2D. And um and on the y-axis we have the concave point mean, and on the x-axis we have the radius mean. Uh okay. Sorry, you guys should just give me a minute, please. I'm sort of like distracted. I'll share my screen back soon. Hi guys, so I'm back and sorry for the delay. So I would not be able to do a lot of things today, and that's because oh shit, I was unable to prepare a project to present to you guys. So I had to find something like comprehensive so that you can all understand what decision tree is basically. So first off, it's it's as simple as an algorithm, just like linear regression or forest random or linear regression and all of that, or random forest. Um, decision tree is also another type of algorithm that we use in machine learning, and we mostly use them in classification and regression problem. So it helps to find linear and non-linear relationship between features and the labels, or should I say the targets of the data set you are working with. And so let's just have a quick look on how it works exactly. Okay, so what is decision tree? So decision tree is basically like a map. It helps us to map out decisions and the outcome. So like you have the what you're trying to predict, and no, basically you have the features, right? And if particular feature can help you predict if something is yes or no, or if something is, this amount or that amount, like it helps to check like ranges of stuff, or like, zero or one or something. Um, just move to this place. So how does it work? So you have the root node. The root node is usually like the feature itself, and it checks the feature. Does the feature have this? If yes, then it asks more questions based on that feature, or let's say more features. So we can look at it this way. Let me just bring out like a presentation so you could like draw on a whiteboard or something. So you could look at it this way. You have a okay, just hold on a bit. I'm using this. I also want to use the pen. Okay, we could look at it this way. You have a circle, and this circle is basically contains your features, right? Basically contains your feature, and then you are trying to use this to predict or to create something. Let's say it's a triangle, right? It's a triangle, and in this box, or let's say in this data set, we have like this, right? A black circle, we have a red circle, and then we have a let's say blue circle. Yeah, a blue circle like this. So uh, let me clean up this rectangle. So I want to like make it clearer. So let's say you have one part of the triangle black, then you have another part of the triangle red, and then you have another part of the triangle blue. So now this, right, is what makes up the triangle. So when we are looking at this feature or the data set, we are trying to check, okay, what does this data set have? Does it have red? If yes, okay, let's check. Uh, just hold on. Okay. So we are trying to check this feature. Does it have red? So if red is present, red. So I'm trying to draw like a tree, right? So it has red. If it has red, it's going to be in two ways, right? Like this. It can be one or zero. So I'm using one to represent yes and zero to represent no. So if it has red, then we now check again. Does it have blue? Let's just say blue. Or let me just use B. I'll just use B because it's like shorter. Does it have blue? Let's say B. Um, then if it has blue, we're still going to like go through the same process of checking, you know, and then we say yeah one, we say yeah zero. So if you guys can look at it, if you guys see this thing very well, we can see that we are sort of like forming a branch. And in this branch, we're like checking each features and we're making sure that okay, it contains some certain things before we can decide that yes, this is a triangle. So in all of this, what we are trying to predict is this a triangle? So now the last thing is to check if it has black. Does it have black? Let's use small letter B as black. It has black. So it's also a yes or no thing, right? So now if it has red, we should check if it has blue. But before we check if it has blue, if it does not have red, then we say that it is not a rectangle. So we can just put here as I mean a triangle. So we can just put here as zero. So if it does not have blue but have red, then it is still not a triangle, right? And then if it has red, blue, and black, then it is a triangle, which is I can represent it as one. But if it has red, blue, but does not have black, then it is not a triangle. So before like I continue, do you guys like do you guys understand what I just explained now and how like decision tree works? I need like a response, maybe a thumbs up would do. Are you guys with me? Kiwi, what are you thinking about?
Can you go over it one more time, please?
Oh, you want me to go over it one more time?
Yes,
All
please.
right, all right. So we're talking about decision tree, and I was saying a decision tree is basically just another type of algorithm that we use in machine learning, and we use it for classification and regression problem mostly. So we also have like the linear regressor and the other types of algorithm which we did last time. So unlike linear regressor is pretty straightforward. It just checks for the linear relationships between the features and the labels or the targets. But now when you're working with a decision tree, you're not just checking one part of the feature or just two parts of the feature. You're checking the entire database and you're trying to see, okay, what is supposed to be in this database to make sure that yes, the target is present or is not present, or determines what kind of value the target would have, right? So I only use those illustrations to explain how decision tree works. So how does it work? You have a root. The root is basically your database, and then you have like your target, what you are trying to get in your database, the value you are trying to get, if is a yes or no, or just like random values in regressors, right? So I explained that you need to go, what it does is basically go through these features. So unlike just linear regression where you go through just one feature and you see if it's there or not, and you just conclude, oh, this is the value of the target. It goes through the feature like thoroughly, like it checks is A there. If A is there, then let's check if B is there. Then if B is there, let's check if C is there. I'm like making this more comprehensive for you guys so you can understand, right? So now I gave this illustration of a circle, and in that circle, we are trying to determine a triangle. And in the triangle, it is made up of three lines, and those lines are black, red, and blue. And so in this data set, not everything is obviously black, red, and blue. Some are black, some are red, some are blue. And how decision tree works is basically checks it, right? It checks, okay, first let's check if it has red. If it has red, I represented yes as one and no as zero. And I'm like, okay, if it has red, now let's check if it has blue. And I represented blue as capital letter B. Now, if it has blue, let's check if it has black. So I represented black as small letter B. And up until we now see, okay, hold on. So up until we decide that it has every single features, and we can determine that okay, this is now a triangle. Oh, no. Ah, this is not right, but you get like it's basically just a rectangle. I mean triangle. I don't know why I'm mixing up the shapes, but yeah, like Kiwi, do you understand now? Like, do you understand? I'm only just trying to use that to like make you guys understand what like decision tree and how it works. Okay. So I'll just clean this up real quick because like it's boring. What should I say is lame? But yeah, let's move on. So yeah. So this is it right here. So like you start with the first question until you determine that okay, yeah, I have the right answer, and yeah, you can see you've reached a decision, and that decision determines what your target value is. So this is how it works in classification, and this is how it works in regression. So in a classification problem, it's like pretty straightforward. So you use the decision trees in classification to just like train decision using decision tree, and you use to determine your target value. And basically, what it just helps us to do is to, like it's either just improve our model or like we're just trying to test different model and see which one is better. So decision tree on like linear regression is like you can use to get like non-linear results from from your uh from your like more linear results, right? And your model basically just perform for. And then these are like some of the applications that we use decision tree in. So imagine someone that is sick. Let's say the person has malaria, right? Now, malaria has symptoms, and the symptom can include fever and tiredness, and then let's say fatigue and dry face. Let's just say it has its what's it called? It has its features, right? Before we can determine that someone has malaria. So how do you diagnose this? You check it one by one, and you make sure that every single one of those symptoms are present before you can say, oh yes, you have malaria, right? And it is still basically how I explain the whole like triangle thing for you. So until you actually realize that every feature that was mentioned is there, then this person has malaria. So the same goes for loan approval. Before you can get loan, you have to have a collateral, you have to have a guarantor, you have to have a constant stream of income, you have to have like some, you have to be at a certain age, things like that. So how does it work? I'm using decision tree to train for who can actually get a loan or not. And I check, okay, so does this person have a guarantor? If yes, now let's check. Does he have something he can use for collateral? If yes, now let's check. How old is this person? What age range is this person? Is the person between the age range of 18 to 34? If yes, okay. Does this person earn at least nothing less than, let's say, 500,000 in a month? If yes, then we can give him the loan. If no, we are not giving anybody loan. You get. So like, yeah, from all of this, you guys can see that it's basically still the same application that is being put in place. So yeah, I think that's like pretty much it in terms of the explanation in the decision tree. So does anyone here have a question, or do you guys get the whole concept?
Pretty straightforward so far, I think.
Yeah, so when you were like learning on data camp, did you have any part that was like kind of confusing for you?
For me, I would say loss, error, loss, I think, or something
Loss.
like that. Yes, loss.
Uh, loss. Uh, did I not explain loss for you?
Like it was explained, but I don't know, I feel like I'm still not getting it.
Uh, okay. So I want to just like do a quick sample, like example, before before we move on how like decision tree. So I'll be using this code. So for us to use decision tree, we basically import decision tree from psychic length tree, and yeah. So this code basically just involves the dataset, which is like make moon, yeah, make moons, and then I'm importing the algorithm decision tree classifier, and then we already have like the samples, which is like X and Y samples, which we can then fit into classifier. So the decision tree has like a few parameters which you can tweak or fine tune to improve it, right? So our minimum sample is 5 here, and then we have the random state. Remember, the random state just helps you to make sure that you are getting constant results. Now, for the minimum sample leaf only helps you to make sure that it is not sampling the entire database. Like it's just sampling like a few parts based on what you selected, and it's using that to determine the label or the target value. I think someone sent a message just now. Oh, someone just joined instead. Okay, Chima, you said you have a question. You can go on.
Sorry to cut you short. Sorry to cut you short. I don't know if it's just me, but I don't know how you got to where you are now. I'm not sure I know
No,
what
you
you
don't
are
know.
doing currently.
I already explained. Okay, I will explain. So here's the thing. I already explained what decision tree, right? Did you follow that?
Yes, I did.
Yeah, you saw the whole illustration, right?
Yes, I did. Yes, I did.
Yeah, so now I'm like going into how to use it. Like you understand decision tree. Okay, now we want to use it in machine learning, in creating a model, in training model, in fine tuning. That's basically what I'm just showing you. That's how I entered
Okay.
Visual Studio Code and like I started writing code and showing you like
Okay.
yeah, or maybe I feel like
Okay.
maybe this one might be a bit complex. That's why. Okay, so let's just go through like um we can just go through some of this. Yes. So here's it, right? This is decision tree, and we just trained a model, or we just feed the model into a data set. But then, like I was explaining some of the few things that um decision tree has. So decision tree has its own parameters, and these parameters you can always tweak them to get the kind of results you want. So majority of the time, the parameters we use is rather max depth, minimum sample split, no minimum sample leaf, maximum leaf node, random state, and max feature. So like these are like the most common parameters that we tweak in decision tree classifier. And yeah, as usual, you initiate your initialize your model, which is what I just did here. I just initialize it after importing. So for you to use decision tree, you need to first import it. How do you import it? You import from scikit-learn.tree, then you import your decision tree classifier, and then after you import, you initialize. Then you fit your model into the data set. Okay, you have another question. Yeah, go on.
Sorry to cut you short again. Please, can you explain what's happening in the third line of code?
In the third line of code, is it this part?
Yeah, yeah. What's happening there? I'm not quite
Okay, so this
sure
is
what's
just like is a normal stuff. Um, so what I'm doing here is I just imported a sample data set from scikit-learn. So you know scikit-learn have like their own inbuilt data set, and I used the one last time, which was missed. So this one is make moons. Honestly, I don't even know what make moons is, but like this one is just another data set that we are training, and we are only taking just 150 samples from it. Yeah, like that's just it. Like it's not. I don't want to make it too complex, but like I don't think it's that complex. But we can also check this one out too, which is um which is another type of data set. So an this is another data set from scikit-learn, which is good iris. So you can always get good iris from scikit-learn. You don't need to download this from anywhere, it's always there. So this data set we are using, this is our model, which is decision tree classifier. And then in load iris, all we just did was I brought in the iris. So this iris too is like a image data set, but it comes with the target and the data itself. So I selected the data I need from from the data set. So the only data I got there was just the palette length and the palette patal or petal rather. Yeah, petal length and the petal width. Those are the only data I took there. So basically like iris just contains the petal length and petal width. And then I took the target data set. Then I initialized my decision tree with the max depth of two, just two. And I feed the model into the data set. And it's it trained the model using what I gave it. Basically, like I just trained the model. I don't think I did stuff here. I didn't want to use this one to teach you guys because I didn't complete it. But like, yeah, this is just how it is most times. So let me just like finish up this other one. You guys can see my screen, right? This is like a
Yes, we can
different,
see it.
yeah, this is like a different resource I'm using to what's it called? To just teach you guys. Let's continue. So using this thing. So when so the first thing we just created was the set itself. So now I just like added the test set using 1000 samples. And in this part, we want to test it. So we are testing using entirely new features, right? So obviously we can test using the score as your matrix. So let's just see. So what are we using? Let's use the first classification, then we can use the second one. Okay, we fit in the first. But it's the same thing now. Okay. So now here's the thing. You have your first decision tree classifier and the second one. The first one, you did not tweak any parameters. Like the parameters are just by default. Then in the second one, what we tweaked there was the minimum sample leaf and the random state. Just the minimum sample leaf, rather. So now I want to add just one more, which is like max depth. So we are going to train on another decision tree classifier. So let's just say tree TLF, which is transcription tree. So just say decision tree classifier, giving a max depth of let's use a max depth of 3 and it keep the random states. So now let's now rerun this so that I can train it. And then this is the test set to be used. So from here you can realize that your initial data set you are using to train or to fit your model is quite different from the test set. So in this test set, we are using like 1,000 samples. And now let's train or let's try to see what score it will give us. So we'll just say 3 classification 1 dot score. So we just input x on test comma y on test. So when we check the score, we have 89 0.898. That's the score for the first one. So I'm going to just copy and paste this. All I'll just change section tree I am using. So in this one, I'll use the second one, which give us a better result. And now let's check for the third one. What's wrong? This one for instance. Okay, oh, I did not fit the model. So I can fit the model here and also like get the score. And also get the score. I forgot to fit the first model. The third model I created. So remember, we are fitting to X moon direct, not X moon test. Just X moon. So now if we change this, okay, so this is nice. So from this part, we can see that we have the first one, which is 898. It's not bad, but it got better when we fine tuned it, and we are able to get like 0.9, which is like a very good model. And then for the third one, we got 0.914. So just tweaking the max leaf was like much better. So let's change the max leaf to, let's say, 10. Can change the max leaf to 10. And we wait for it to train. Yes, so since we've trained it, now since the max leaf is in classification 2, then let's check it. So at the end of the day, we realize that the max leaf, when we tweaked it to 10, it's performed lower, in fact, lower than when you do not even tweak it at all. So now it means that max leaf 10 doesn't work or it's not performing well. So let's use, you have to just stick with it. We'll train it back and then we should be getting our 0.92 back. Okay, it's even performed better, 0.35. So yeah, like I feel like have you guys done fine tuning or hyperparameter tuning before? Hello? Okay, cool. So we're just going to do a bit of fine tuning too, and we'll just see what it gives us and all of that. So yeah. Shima, you have another question. Shima, you raised up
I'm
your.
sorry, but no, I'm sorry, I proceed on you.
Oh, was it a mistake?
Yes, it was a mistake, sorry.
Okay, fine. Let me just move on then. So this is just for like, this is actually like for a regression problem, just like for a regression problem. So remember, who can remember what code you used to check what kind of what's it called? What kind of data you imported from scikit-learn? Okay, no, it's not this. There's a R there. And let me use this come out though. Why is it looking weird on this? Ah, what's wrong? Just give me a minute. I don't know why this is not working for. Let me check from the last one. Where is it? So, oh, sorry. I'm trying to like get this info before making it so that we are all like on the same page. Or I can even just use plot to get directly. Okay, so okay, so it's just basically a classification problem. It just has like okay, the two classes overlapping questions pattern, the features. Okay, so this make moon is basically just a classification problem with two features, which is x1 and x2, and the classes of 0 and 1. So it's just between like 0 and 1. That's just it. And the samples, we just use like 100 samples so far. Um, I think that's just it. It's not like a serious data set. There's nothing like serious about it. Just a data set with two features of x1 and x2 that we are using to see how decision tree basically works. And yeah, I think that's pretty much it. Yeah. Yeah. And you can always like fine tune and all of that. You know. Yeah. Do you guys get the whole thing I just like did today? Hello? Do you guys get what I did? Did you guys get all the things I did today? Please, if like some parts are confusing, I can explain. Just have to talk. Okay, so I think it's time for my own question. Yes, yeah, it's like time for my own question. So I don't even know what to ask to be honest. Let me stop sharing my screen first. Then I'll ask my question. I have like a few questions. They are not complex, don't worry. Most definitely not complex. So like, can you guys mention the kind of data sets we use? Can anyone mention the kind of data sets we use? Decision tree, algorithm.
You mean in this project that you um,
No, I
for?
mean like normally if you're working on a project, like what kind of project would you implement decision tree on?
Okay, what kind of projects is the decision tree model useful, right?
Yes, I'm saying like in what kind of data sets do we use it on? That's what I'm asking.
Okay, okay. Um,
You guys are not following me. Can anybody else answer the
okay,
question?
like data sets from like medical field or like a credit system.
No, no, that's not what I'm asking. Okay, so basically, like all of these data sets can be classified under supervised learning, right? And I'm saying that we use it in classification and regression problem. I already like explained that from the beginning that we use it in classification and regression problem. So like, do you get that part now?
Yes, 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 yes.
Okay, so now my second question is how can you make decision tree to perform better?
think by hyperparameter tuning.
All right. Um, so another question is between decision tree and linear regression, which one mostly would give you the best results?
Decision tree.
And why is that?
I think because it uses both the linear classification to like join the result together.
Okay, so it's two reasons here. The first reason is that it doesn't just check for linear relationship, it also check for non-linear relationship. That's one. And the second reason is you can, tune the parameters, making it to perform better than it did or than linear regressor. So like those are the two reasons, right? So who can tell me how you import decision tree classifier or should I say decision tree? Did you guys get the last question I just asked now?
Yeah, we can import it from sklearn.tree. That was asking.
Yeah, sklearn or tree from sklearn or tree import decision tree classifier. So that's how you do it. And then when you initialize it, is when you should fine tune it. But there are other ways of like doing that. That one is like later on you guys will get to do all of that. But like for now, you fine tune when you import. So later on we'll learn things like imputers, so like simple imputers. So in simple imputers, what that one helps us to do is you can be able to fine tune. It's like you're creating a variable, but that variable is for fine tuning, right? And you can easily just change your parameters values to fine tune your models, and you can fine tune more than one model or two algorithms rather using simple imputers. But you guys will get there. But for now, like you can just simply fine tune directly. So yeah, so yeah, um, yeah, like I think that's pretty much it. Yeah, that's pretty much it. So, like aside what I just put you guys through, I made it extremely like much more simpler for you guys. But decision tree, if you want to like really go in depth, like kind of more complex than that. But I just made it like much more simpler for you guys because making it complex would just be complex for everyone, right? So now that you understand decision tree classifier, um I want you guys to like train it on some of the models you've actually done, and everything is basically just the same principle. And what's this principle? You import your model, you import your algorithm rather, your data set, you train the data set. But before you train data sets, make sure you split it into train and test sets, right? So your train set will be what you use to fit the model to make sure that you are training that out, you are training using a particular algorithm. And then your test set is what we use to test the model to make sure that it's performing well. And then you can check using different matrices. So you can test using like the accuracies for root mean square, the recall, the precision, and all of that, you know. But like most times in decision tree classifier, you mostly test using just the score alone. I feel like that alone gives you what you need, right? So decision tree is not that complex, right? And I've given you all the necessary things you need to know in it. And that is basically what is being done in data camp. So you guys can just go ahead and implement it into classification problems, regression problems, use it to make predictions, use it to get like root mean squares, the mean square error, and all of that, you know. Like, I think you should be okay just with that, to be honest. So are we good now? I need responses. Like, you guys are not even responding. That's the problem I'm having. So are we good? Like, were you guys able to understand this class? Yes, I just need your response. Like, so normally our last few classes were like more interactive, but today's on, I don't know why you guys are like, I don't know, very, very silent. You guys can, you know, talk. So yeah, do you guys understand? Um, I need to even send the attendance. Just give me a second now. Paste it now. Uh, so you can send your attendance here. And yeah, like we're done for today. That's it for decision tree. Yeah, that's just it for decision tree. So yeah, I want to hear from, okay, I'll just pick two random people. I'm going to ask you guys just a very simple question. So first off, Kiwi, are you with me?
Yeah.
Yeah, so were you able to like really understand, okay, first off, like how decision tree works and how to implement it, and the like benefits of using decision tree?
Yes, I get the general idea of how decision trees work, but I think I'd have to read more, like, or rather, I think it's more practice. It's more practice that I need here.
Okay, let me just tell you something real quick. Just like every other algorithm, like linear classification, right? Or linear regression, sorry. Yeah, there's also linear classification. So like it's basically just the same implementation. Like no matter how much you want to practice decision tree, it's still just the same thing. All you're doing is you're importing the algorithm, right? And then you are initializing it. Now you can choose to initialize it with the default parameters, which means you are not fine-tuning anything. And then you train using it by fitting it into your data set. Then, or you can decide to tweak the parameters to increase the performance of your model. So it's not complex, right? It's not complex. The only thing I just feel like you could, check out more is the okay. Let me listen to what you're saying.
Okay, like are there specific use cases where you'd say this algorithm doesn't work well? Because in the way that you're describing it, it sounds like it would work well for most use cases, but then people
Yeah, yeah,
don't
yeah.
use
So
it
there
for
are
all
cases
cases.
where it doesn't work well, and that is why um I don't know if you guys have done underfitting and overfitting. So in cases where like your model is underfitting or overfitting, right? Um, it might not be like the best to use because it's either performing too well or performing at the least. So the reason why like decision tree is like a really good model to use is that algorithm rather to use is that when you fine tune it, when you fine tune the parameters, you can make it to perform better. You can literally make it to perform better. So it's like one of the best options when it comes to picking the algorithms to use because it's not just checking the linear relationship between the features and the labels. It's also checking like the non-linear relationship. So you're not just checking one feature and saying, oh, just this one feature is there, and you're saying, oh yeah, we can use that one feature to predict our label. We are checking the entire thing, like the entire thing literally, and making sure that we are not missing anything. Because decision trees, like for example, we use it in like very, very sensitive cases in terms of like medical diagnosis, right? You wouldn't want to be the kind of doctor that would um diagnose a patient wrongly and tell the patient he has cancer where the patient is just having maybe stress anxiety or like just a minor disease, right? So yeah, decision tree definitely works in a lot of like use cases. But like, fine tuning it is very important to make sure it performs well. So like, do you get that part now? All right. Um, so someone else asked a question. He said, can you please help recap the difference between decision tree models and linear model classifier? So linear model classifier only works for classification problem. You can't use linear classifier for like say like a regression problem. You just get it all wrong. And decision tree is used for both classification and regression problem. And it helps to check not just linear but non-linear relationship between features and the labels. And in decision tree, you can easily just fine tune the parameters, like some of the parameters to get like better results. Yeah. A linear classifier is a like lower kind of algorithm. Yeah, it's not as strong as decision tree. So, we just use this to test. Really. That's all we use them for, to test which one performs better. Um, Emmanuel Kolawole. Uh, let me see. Let me see if I can send the link to you. I don't know if that's possible. Like that would, um, okay. I don't know if this is even the link, but like you can just try. So who else have another question to ask? Yeah. And if you don't, I'll be leaving in the next 10 seconds. Okay. Someone has a question. Yeah, go ahead. What's your question? Yeah, the recordings are always sent to the announcements group on Discord, and it's majorly up, like they are mostly uploaded on YouTube. So you can always get the recordings from there. The previous session and this one we are doing right now, everything is recorded. So yeah, I hope I answered your question. Do you also have another question? Okay, so I'll be leaving in another 10 seconds in case anyone has a question. 3, 2, 1.